Hi everyone, welcome back to the wonderful world of limits. In this particular video we will spend some time discussing the special limit forms. Some 0 over 0 forms cannot, at least not at this time, be solved by using strategies we've introduced, such as factoring and cancelling, rationalization, or simplifying fractions. As a result, we're going to present these as special limit cases. We're not going to prove their validity, but you are always welcome to use a numerical approach to at least verify that they are accurate. So here are the special limit cases. The first limit is when x tends towards 0 for the function sine of x over x. You can tell that direct substitution will provide a 0 over 0 result. Factoring, rationalization are both out of the question here, and therefore we will assume this limit is equal to 1 when x is measured in radians. You can verify this is true by numerical approximation. The second limit form is for an x value approaching 0, the quotient of cos of x minus 1 over x will tend towards 0, once again assuming x is measured in radians. As before, if you were to try direct substitution, you would see a 0 over 0 form arise from this limit. So we're going to take for granted this formula actually works. Finally, there is a limit where x tends towards 0 for the quotient e to the x minus 1 over x. This limit, which provides a 0 over 0 form by direct substitution, tends towards 1. In class, we've actually seen that this limit, e to the x minus 1 over x, as x tends towards 0, will tend towards 1 by using a numerical approach. In fact, we've even verified that this rule can be generalized to other base exponential functions, where if a is the base, then as x approaches 0, a to the x minus 1 over x will tend towards ln of a. You can probably see the connection where in the case where a is actually equal to the natural number e, ln of e would be 1. So these are in fact the same identity, one being a particular case of the other. Now, don't be misled by the symbols, because whether we use the typical variable x or whether we use any other type of symbol, as long as the form of the special limits is respected, then their values are still valid. So whether we use hourglass instead of x, or pentagon, or smiley face, or the and symbol, then these limit forms all still apply. Let's compute the following limits. So first of all, as x tends towards 1, sine of x minus 1 over x minus 1. If you were to attempt direct substitution, you would definitely find a 0 over 0 form. Here's what you should, here's where your attention should be caught. Do you notice that the angle in the sine function and the divider are identical? So this looks a lot like the special limit forms that we just presented. Actually, what really matters is that both of these numbers are the same, but also tend towards 0. Well, actually, when x tends towards 1, x minus 1 will tend towards 0. So what I've just boxed could be the equivalent of the hourglass that we had in the previous example. So the sine is calculated at an angle whose denominator is exactly the same, and both are heading towards 0. And therefore this limit will tend towards 1 since it fulfills the special limit form. Here's a similar example where we have cos of 1 over x minus 1 divided by 1 over x. Once again, we have the exact same angle inside the cosine as the divider that appears at the denominator. Having the same angle, will allow us to use the special formula because in this case, the second of our special limit forms is satisfied. We haven't seen this yet, but 1 over x actually does tend towards 0 when x becomes really big. So this would be the equivalent of our pentagon a few slides ago, where we have an angle going to 0, a divider going to 0 at the same rate. Last but not least, we have this last form, which would be of a 0 over 0 type if we tried direct substitution. What we can observe is that the exponent v and the divider are exactly identical, so the equivalent of our happy face a few slides ago. And as x goes towards 3, it forces 3 minus x to head towards 0. So now we have an exponent and a divider which are identical, and we have those two numbers both going to 0 simultaneously. So once again, the special limit form for e is applicable, and the result of this limit will be 1. So this is really more recognition than actual algebra.